Another way to solve systems of equations is using linear combination. And linear combination is basically like adding the two equations together so that one of the variables cancel out. Another term for this method is called the elimination method because you're eliminating one of the variables when you're combining them together. And this method is actually a faster way of solving systems of equations than graphing and then using the substitution method. So if you can remember that we're basically stacking and adding these two equations so that the variables, one set of variables cancels out. So if I were to think of this as one big addition problem and I add vertically, when I add 2x plus a negative 2x, it equals 0. They cancel each other out. And so when I continue to add now a y plus a negative 7y, this is like 1y plus negative 7. This would equal a negative 6y, and then 5 plus 13 would equal 18. And so what's nice about linear combination method is now I'm only working with one variable because one of mine canceled out to equal 0. So now I just need to solve for y. With the equation negative 6y equals 18, I can divide by a negative 6 on both sides and get y to equal a negative 3. This means that in both equations, y is equal to a negative 3. So now we have to finish solving to find what x is equal to. So we can take one of our original equations and replace y with negative 3. So the equation 2x plus y equals 5. If I substitute in negative 3 for y, I would have 2x plus a negative 3 equals 5. And then inverse operations of subtracting 3 would be to add 3. It's the opposite. It'll cancel it out to equal 0. And we have 2x equals 8. 2 times x, the opposite of multiplying by 2, would be to divide by 2. And we find that x equals 4. So our solution to this systems of equations is the ordered pair 4, negative 3. And it is important to check your answer for both equations. So if we check for our first equation, if x is 4 and y is negative 3, I would have 2 times 4 plus a negative 3, and I want to see if that equals 5. So 2 times 4 is 8 plus a negative 3, and 8 plus a negative 3 is 5. So checked out for our first equation. Then you want to check for the second equation. So our second equation was a negative 2x minus 7y equals 13. And if x equals 4, negative 2 times 4 minus 7 times a negative 3, I'm trying to see if that equals 13. So negative 2 times 4, that's a negative 8, minus 7 times a negative 3, that would be a negative 21. And adding the opposite, negative 8 plus 21 does equal 13. So it checked out for that one too. So the solution to this systems of equations is the ordered pair 4, negative 3. So x is 4, y is negative 3. This means that this is the coordinate where these two equations intersect. Another example, when looking at this one, notice if I were to try to add these two equations as they're written, 4x plus x, I would get 5x. 5y plus 5y is 10y. And negative 5 plus 10 is a positive 5. Notice how nothing canceled out. So in this case, since the two signs are the same, I have matching coefficients, but the signs are the same, I can't actually add them. So instead of adding, this is one where you would actually want to subtract. But it's important that you subtract every single term. So one way of thinking about this is just making sure that you subtract 4x minus x, and then 5y minus 5y, and a negative 5 minus 10. The only tricky part with this that I've seen is students will forget to subtract everything. So they'll subtract this first one, but they'll forget to subtract some of these other ones. So another way of writing this that would change it to an addition problem is if you change the sign, so you're actually adding the opposite of each of these. So you could actually write your equation as 4x plus 5y equals a negative 5, but then change the sign of everything. So negative x and a negative 5y and a negative 10. Now you can write it so that you're adding the opposite. Now it's just one big addition problem, and you can add the terms. You'll end up with the same answer. So 4x plus a negative x is 3x. 5y plus a negative 5y is 0. And negative 5 plus negative 10 is negative 15. So our equation is 3x equals negative 15. Dividing by 3 on both sides, we get x to equal a negative 5. Okay, using our other method, if we were to subtract, 4x minus x is 3x. 5y minus 5y is 0. And this is where students would make mistakes. They would add negative 5 and 10 and write this as a positive 5, but it's negative 5 minus 10. Negative 5 minus 10 is equal to a negative 15. So sometimes it's easier to change the sign of everything so that you're writing it as an add the opposite problem, so the opposite of each of the terms, and then you can just add the two equations, but you should end up with the same answer. So we found our x to equal negative 5. Now we just have to find y. So if we plug in negative 5 for x into one of our equations, we would have 4 times a negative 5 plus 5y equals negative 5. And this is a negative 20 plus 5y equals a negative 5. If we add 20 on both sides to get it to cancel off over here, because negative 20 plus 20 is 0, you end up with 5y equals 15. And dividing both sides by 5 to get y by itself, you have y equals 3. So our solution to this system of equations would be the ordered pair negative 5, 3. And it is important to check your answer. So again, doing our check with your first equation, 4x plus 5y equals negative 5. 4 times a negative 5 plus 5 times 3, we're checking to see if that equals negative 5. So negative 20 plus 15, that does equal negative 5. So our first equation checked out. Make sure you check with both. So if I check my second equation, x plus 5y equals 10, where x is negative 5 and y was 3. We want to see if that equals 10. Negative 5 plus 15, that does equal 10. So that one also checked out. So in some cases, you may have to subtract the two equations to get a term to cancel out. You'll know you have to subtract if the signs aren't opposites. And if it's easier, you can rewrite it to an addition problem where you add, but the opposite of each of these signs. Make sure you change the sign of each of those terms, and then you can just add, like you did in the previous example, to find what your variable is. The other example, when the signs are opposites like this, you can just add, and then you'll get one of your variables to cancel out, and you're left with just one to continue to solve. Make sure that you double check your answers. Do the check for both equations to ensure that your answer is correct.